Well, hello to all good people of the world. This is Paul Whittakin returning to you today with the universal law of numbers. And what we're going to be discussing today is the universal law of numbers, how it has its codes and how those codes relate to the Fibonacci numbers, and how the Fibonacci numbers relate to phi, and how phi relates to the universal law of numbers in that fashion. So basically, there's no prerequisites to understand what we're doing here. As long as we can add numbers, we'll be fine. And basically, what I want to demonstrate is that whenever there's a system that involves nature, whether it's genetics or music, the Fibonacci numbers, for instance, they describe nature, and it's a code that's embedded throughout nature that you see manifesting itself in galaxies and plants and animals, etc. And it's our world arithmetic. We go 0 and 1 equals 1, 1 plus 1 equals 2, 2 plus 1 equals 3, 3 plus 2, 5, 5 plus 3, 8, 8 plus 5, 13, etc. And that does go to infinity. So what it does is it gives us the 369 code. It's embedded within. And what we will see is that if we start here at 0, and we go 1, 2, 3, 4. So every fourth. 1, 2, 3, 4. 1, 2, 3, 4 will give us the code 339669, and that will continue on like that to infinity. That is a distinguishing feature of the Fibonacci code as it's expressed, the universal law of numbers code expressed in the Fibonacci code like that, 339669, which by the way is 396693. So it's the 369 code. For instance, the universal law of numbers goes 696969 and 699699699, and that's the 369 code. So what we see is if we start from here, it'll be 0, but then it's going to go to this sequence, 339669. Very good. Okay, so in order to arrive at phi, it has been well understood for some time that if we take any of these Fibonacci numbers, and we divide it by the number that precedes it, that we will get a result that resembles phi. And the further we go down in this direction and repeat that operation, the closer that number will approach the actual value of phi. Now, phi doesn't have an actual value because it's a number sequence that goes on forever. Fibonacci is a number sequence that goes on forever. The universal law of numbers goes to infinity. However, the codes remain the same. So if I divide 21 by 13, quickly do this on a calculator I have sitting on my lap. 21 divide 13, it's going to say 1.6153844615. So 1.6153. Okay, but now if we go down to here, let's say 89 over 55, divide that, and I know what that one is. It's 1.6181181181. I'm going to check that one, but I remember that one because I think it's interesting. I did 89 divide 55, I think, yeah, 1.6181818118. So that's closer to the precise value of phi at that moment than the first one was. And it may be logical to conclude, I do at least, that these number sequences, irrational numbers that go to infinity, etc., as Fibonacci does, they are expanding with the universe. So if I were doing the Fibonacci numbers and I got to here, and that was the right answer, well, it's already too late because it's already gone beyond that. With phi, if I got 1.618 and I finally got to the last digit and it was still the correct one, it would be too late because it's speeding, expanding these numbers with the universe, and evidently at the speed of light. For instance, this right here, 857,142. Okay, so whenever we divide a number by 7, we're going to get the 248751 code in all of its forms. And if it's 857142, it's going to go 857142, 857142, 857142. So if we got 857142, and then it's 8, and we're there, well, it's already 57. It's going to continue on to infinity. So basically, if I can divide this number here by the previous number in the Fibonacci numbers and arrive at phi, then theoretically I should be able to get some relationship with that, some correlation to that relationship with doing it my way. So doing it my way, I'm going to divide these codes, the first one, 339669, by the previous one. So this one, it'll start at 0 over nothing. But then it'll go 3 over 2, then it'll go 3 over 4, then it'll go 9 over 8, then it'll go 6 over 8, then it'll go 6 over 5, then it'll go 9 over 1. And then it'll go, I didn't get that far, but it will go 3 over 2 again because it's a repeating sequence. So if I just, do that, 3 over 2 equals 1.5, 3 over 4 is 0.75, 9 over 8, 1.125, 6 over 7, just like any number over 7, is the 248751 code. And 6 over 5 is 1.2, 9 over 1 is 9, 3 over 2, 1.5 again. Okay, so these numbers, now 7 does that. 7 is a transition point always, and we see that a lot. We see that with this thing right here. Anybody recalls anything about that? But what this provides is, in effect, it can be any number, like a wild card or a joker in the deck, because from this we can get the numbers 2, 4, 8, 7, 5, 1, and we can also get the 3, 6, 9 numbers, which is different than the 3, 6, 9 numbers, because the 3, 6, 9 numbers you cannot get 2, 4, 8, 7, 5, 1 numbers from 3, 6, 9 numbers, but the 2, 4, 8, 7, 5, 1 numbers, you can get 2, 4, 8, 7, 5, 1 numbers and 3, 6, 9 numbers. And if you take the number 3, 6, 9 and you multiply it by a 3 or a 6 or a 9, it's always going to be a 3, 6, 9 number. If you add a 3 or a 6 or a 9 to a 3, 6 or a 9, it will always be a 3, 6, 9 number. So anyway, now, if I reduce those numbers, I'll get 639,396, which is the 369 code. And if I want, and I do, and I have, I can also reduce those fractions in this format. 3 and a 2, that equals 5. 4 and a 3 is a 7, so we're going to get 5, 7, 8, 4, 2, 1. 5, which is 1, 2, 4, 8, 7, 5, 1, 2, 4, 8, 7, 5, 1, 2, 4, 8, 7, 5, 1, which we all know what that is. So we get the 369 code 248751 here. We get the 369 code 248751 here, and we get the 369 code in this fashion, 339669. So we learned something about that, and we will continue, but one thing that we might learn is how we can treat the 369 numbers in a different way that we treat the 248751 numbers. And even though they're doing the same thing, in effect, they have a little bit of a different, it's something you can do to treat them separately, and you will begin to understand a little bit better how the system is working in its entirety. So, one thing I will point out here is, okay, so from previous lessons, doing this thing here, and even more accurately, I would use this one here. The way I first produced this one here was by multiplying the numbers by themselves. So it's 1 times 1 is 1, 11 times 11 is 121, 111 times 111 is 12321, etc. And we arrive at that, and I drew triangles. So that's what that is. And it's just simple because 1, 1, 2, 1, 1, 2, 3, 2, 1, 1, 2, 3, 4, 3, 2, 1, 1, 2, 3, 4, 5, 4, 3, 2, 1, which is what this is. And in the middle we get this column, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 8, 7, 6, 5, 4, 3, 2, 1. And if we cut that equilateral triangle into 2 right triangles, then we add these numbers up, and what we do is we make triangles out of them. And those are the triangles that we get. The 6, 6, 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. Adding them up, the 2, and totaling them out. This one right on the left-hand side is a 3, the right triangle on the right-hand side is a 3, and together it's a 6, and we get the code 669, 669, 669. And if we care to, and you're a person like me, I do, we can make that triangle keep on going forever. And this first half of it, we looked at it, was 669, and then the second half of it, well, that would not be 669, it would be 6 and 6, which would give us 339, 339, 339. And if we add the whole thing together, that's what we get. So basically, one triangle is 669, 669, and then the second half, the bottom half of this is 669, 669, and then if we add them together, we get 339, 339, 339. So we see how it's all the same code embedded within with its own individual distinctions. And we're going to continue on because that's just the first part of it. So to all good people of the world, I wish you peace and happiness.
It's not a